Good afternoon, ladies and gentlemen. Today we're going to be presenting a topic on analyzing security susceptibilities and the performance of biometrics with cloud computing. My name is John Regola, and my group members are John Mitchell and Brandon Baez. Now, this was originally a term project for SRA 221 for Dr. Syed Rizvi. However, after we presented our first presentation in class, Dr. Rizvi approached us saying that he liked our idea and he thought it would be a good idea to send a proposal to a book. So we made a proposal for the book. Our proposal got accepted, and now we're in the process of writing a chapter for a book titled IGI Global Securing Cloud-Based Databases with Biometric Applications. Now, our motivation for this entire project is to address a symbiotic relationship by integrating two growing fields, being biometrics and cloud computing, and how their dynamics will mold the future. Now, this is our basic outline of what we're going to be going over today. Development of biometrics, which Brandon will be going over. Combining biometrics with cloud computing, which John Mitchell will be going over. Vulnerabilities with biometrics, which I will be going over. New developments, and finally, the conclusion.
Over the course of our research, we've identified several challenges and we made our own contributions towards them. The first one is biometric vulnerability issues. And what we've done here is we identify and we educate against possible security threats in order to prevent or mitigate them. Next, we have integration outcomes. How can the cloud benefit biometrics? And then next, we have the optimal design choice. We're talking about the advantages and disadvantages of several key design choices for the cloud. In this section, we are combining biometrics and cloud computing. So first I'm going to talk about the structure of the cloud, then the issues and challenges that biometrics currently face, and then the vulnerabilities in cloud computing. Okay, so first the structure. There are 5 main characteristics that define what the cloud is, as you can see here. And there are also 3 main service models. The first service model, software as a service. As you can see by that diagram there, it's basically the end user. This is where you input your access credentials to access the cloud, so on and so forth. For platform as a service, this is where the operating system is delivered to you over a network without requiring installation. And then finally, infrastructure as a service is basically the IT resources being inputted directly into the cloud's infrastructure. Now, the issues and challenges that biometrics currently face mainly revolve around the high amount of data processing and archiving. Whenever you take up a lot of room, we're not talking gigabytes or terabytes, we're talking about the next step up, petabytes. So basically, this is going to lower the throughput rate and the speed. The generally accepted throughput rate right now for biometric systems should be 6 to 10 people being admitted per minute. However, this standard is currently not met by some existing biometric systems today. And lastly, there's cost efficiency. Whenever you want to make a small change in biometric infrastructure, you have to reformat the entire database. Unfortunately, this is going to drive up the cost and make large-scale use impractical. Lastly, the vulnerabilities of cloud computing. It basically consists of 2 categories, physical and informational. With physical, we're primarily concerned with data loss. This can happen whenever there's a flood, a fire in the data server room, or employee sabotage, in which case multiple organizations would obviously lose their data. And for informational, basically a hacker is trying to exploit some of the cloud's key features, such as multi-tenancy and virtualization. For multi-tenancy, it's proven that you can actually use cryptographic keys, when timed correctly, to capture another user's information. And then next, for virtualization, as you can see by that diagram there, a hacker tries to control what's known as the hypervisor. This is the person that oversees all the guest virtual machines. The person who controls the hypervisor then controls the guest virtual machines, and then they can infect whatever data center that they travel between.
In this section, we're going to be going over the vulnerabilities with biometric security systems, and that can be broken down into physical vulnerabilities and informational vulnerabilities. first one, physical vulnerabilities. That can be as simple as stealing someone's biological data, such as lifting someone's fingerprint, seen in this picture here, or stealing someone's vocal pattern from just simply recording someone's voice. And also a major issue is manipulating scanners. As you see in the GIF there, that is an illustration of somebody walking, which is how a gait recognition sees you. So basically, an attacker can study how somebody's walk and just study it, and if you get that right, you can grant access to somebody's room or door just by studying how they walk, which could be a major potential security issue. And lastly, there's informational vulnerabilities, and that can be deficiencies with scanners, which is a huge problem, or hacking the database. And then there's false acceptance rates, false rejection rates, and equal error rates, which are FAR, FRR, and ERR respectively. And as you can see there in the diagram, a false acceptance rate, say John over here has access to a room and Brandon doesn't. A false acceptance rate is when Brandon is given access to a room when he's not allowed to. That's a false acceptance rate. However, when John is given access to a room but he's denied access, that is a false rejection rate, which leaves John very mad and irritated. And then equal error rate is where the two have to meet in order so that there's not too many false acceptance rates nor false rejection rates.
So for the next generation biometrics, these are the expected designs. For the multimodal biometric system, which is probably what most people would prefer to get the most accurate results, as I've already said, there's going to be a lot of data processing associated with a lot of data being taken up by the multiple systems. This is going to cause a lot slower throughput rate and speed. For parallel computation, basically what we're trying to do here is take one big chunk of data, break it apart, send it to multiple processors, and compile it again and send it back to a user in the form of a decision in order to save on the throughput rate and speed. And then lastly, we have failover, recovery, and redundancy. Failover is going to lead into redundant resources being used. Redundant resources being extra resources, like an extra server, so on and so forth. And then lastly, we need a short-term and long-term recovery plan in case of total system failure. Now the cloud helps because some of the aspects like virtualization actually can support both real-time and parallel computing. Now in order to support real-time, you'd have to use a bare metal architecture instead of a hosted architecture. And for parallel computing, as you can see in this diagram over here, the user sends his data into the cloud. That is partitioned among multiple nodes, each have their own processors. That is then recompiled and sent back to the user in the form of a decision. Now, for dynamic failover, let's just say one of the nodes breaks down, or there's a problem with the system, so to speak. Normally that might leave the system completely inoperable. However, if you think about it like this, if we're talking about the old Christmas lights, if one bulb breaks, all of them shut down. However, with the new LED lights, if one breaks, they all continue working. The cloud is basically these new LED lights. And lastly, there's affordability. The cloud's affordability allows enterprise-level software to be available to the common person. This is due to the fact that the entire biometric infrastructure is directly inputted into the cloud. Therefore, a small infrastructure change will only take seconds, making it very cost efficient.
These are our references. I will now open the floor to any questions.
Any questions?